All right, guys, welcome back. So, in my office for this one. So, last class we looked at just a review on fractions, simplifying fractions. We worked with rounding decimals. We talked about place value. Okay, so just some of the rudiments. So now we're going to get into chapter 2. And there's really only one section. We just call it 2ABC. So essentially what we're doing here is we're combining 2A, 2B, and 2C into just one section. Okay, so, and this is on unit analysis. Okay. So, first of all, what is a unit? Well, it's just a metric that we use to measure something. Okay, so for example, a dollar. A dollar is a unit. It's a measure of money. An inch, that's a unit. It's a measure of length. A pound or kilogram or gram, that's a unit those are units that we can use to measure mass. Okay, or you could say weight, but really mass is more accurate. There are many other measurements. Okay, feet, yards, seconds, minutes, those are measures of time. And I'm sure you guys could think of many as well. Okay, so what we're going to be doing is we're going to be trying to convert a measurement from one unit to another unit. Okay, so if you've ever looked down at the speedometer of a car, I guess they're not this way anymore, but used to, they were the speedometers were analog, they weren't digital, so there was a dial that would move. You guys have probably seen those, but there would be listed the velocity, or the speed rather, in miles per hour, and also sometimes on there it would also be given in kilometers per hour. Okay, a mile is one measure of distance, and a kilometer is another measure of distance. So we are going to learn to be able to convert. Let's say I'm traveling at 70 miles per hour, and I want to know, well, how fast would that be if the unit was kilometers per hour? Okay, so things of that nature. All right. Yeah, so if you look here at the definition, it says a unit is the unit of a quantity describe what is being measured or counted. A unit could even be something like a crayon or an orange. If you say I have 7 oranges, well, that's the unit is an orange. Together, a number with its unit define a measurement or a fixed quantity or amount. Okay. Without the unit, guys, it's just a number. All right. So to do a lot of this converting, we're going to use things that are called conversion factors. And I'm going to give you an example. There's a couple here in the notes. These conversion factors are fractions. So for example, 60 seconds over 1 minute. This is a conversion factor. It's a conversion factor because I am utilizing 2 different units, seconds in the numerator here, and then minutes in the denominator here. But what's interesting about this is that this whole quantity right here is equal to 1, because 60 seconds is the same as 1 minute. So we have the same amount of time divided by the same amount of time, and anything divided by itself is always 1. Okay? Or sometimes you could write it upside down. You could say 1 minute is equal to 60 seconds. Okay? I'll give you another example. Let's see. 1 quart. Okay, so if any of you are in the culinary program, 1 quart is equivalent to 4 cups. Okay? Or I could turn it upside down. So what we have in the numerator and the denominator are the same amount, okay? The same measurement, but it's measured with a different unit. And what this will allow us to do is to convert a measurement in one unit to a measurement in another unit. And you'll see how we're going to do this here in a minute. Okay, we're going to be doing some fractional multiplication, and we're going to be dividing out common units. So, all right. Okay, before we do this, though, we're going to look at some of these key terms. So whenever you see the word per, you're going to think division. So, for example, miles per hour. Well, what that means is miles over hours, okay? It's, in other words, to calculate the speed, if you remember from your high school physics or anything like that, it's distance, which in this case is being measured in miles, over time, which is being measured in hours, okay? You could express speed in using kilometers per hour or meters per second or feet per second, and that is done sometimes. But the word per just means you're going to have a fraction. Okay, so you're going to have something in the denominator, in other words. All right, let's look at the next key word, of. Okay, of denotes multiplication. For example, if I say, if I want to figure out what 50% of 20 is, the word of means I would multiply 50% by 20. Okay, now of course I would need to convert 50% into a decimal. It would be 0.5, and then multiply that by 20, and I would get 10. Okay, so whenever you see the word of, think about multiplication. All right, let's talk about this word here, square. You know why the computer screen keeps freezing up. You guys may not be able to see this, but square, okay? So when we use this word square, that means we're raising something to the second power, okay? Or in other words, we're using an exponent. So if I have something like this, that little 2 up there, that superscript, that's called an exponent. And when that exponent is a 2, we say that the 4 is being squared. Okay, and this literally means multiplied by itself. Okay, well, we have square units that we use, and one of them is over here, a square foot. Okay, so what is a square foot? Well, if any of you have ever dealt in flooring or bought a house or anything like that, you've probably worked with square feet. Okay, so a square foot is literally a square that measures 1 foot in each direction, or in each dimension. Okay, so this would be 1 foot, and this dimension would be 1 foot. And so the area is called a square foot. Okay, a square foot, though, is this whole area, this entire square. It just means it's a foot across on each of these 4 sides. It's a 2-dimensional unit. Okay, so it's used to measure what's called area. Because area, if you're measuring area, you're measuring the length and the width of something. Okay, so square feet. All right, now what about cubic? Well, another example would be, there are cubic units. There are other square square units, by the way, square yards, square meters. And those would be squares that are in which each side measures a yard or a meter. There could be a square centimeter. And there are also cubic units. These cubic units are used to measure volume, because volume is 3-dimensional. Not only do you need length, width, but you also need height, okay, to measure volume, or to measure these 3-dimensional. So the word cubic implies that you're raising something to the 3rd power. And so where does that come from? Well, it comes from a cube. So if you have a square, and you extend it in one dimension, then you end up getting a cube. Okay, this is three-dimensional. A cubic foot literally measures 1 foot long. It measures 1 foot tall and 1 foot wide, or sometimes people would say deep. Okay, so it's three-dimensional. So cubic feet. What things would need to be measured in cubic feet? Well, soil or mulch, things of that nature. Okay, things that are three-dimensional. Fluids. So, for example, water. Water has to be measured using a cubic unit. Cubic feet or cubic yards, cubic meters, cubic centimeters. That's known as a cc. We have other three-dimensional units for measuring volume of liquids. A cup or a teaspoon or a tablespoon, those are also units that can be used to measure water or things that, liquids essentially, okay, that have volume. All right, well, we've talked about this some, so let's take a look at a few examples here. So we're going to start off kind of slow. We've got to be able to remember how to work with those fractions in this section, guys. All right, so example 1 here. It says, I drive 150 miles in 2 hours. How could I find my rate in miles per hour? Well, think about this word per, and that implies division, or if you remember what I said, that means that something is going into the denominator. So miles per hour means miles over hours, okay? So if I've driven 150 miles, that's my distance over the number of hours in which I did it, 2 hours, and then I can divide these numbers. But my unit is going to be this miles per hour, okay? So 150 divided by 2 is 75. So my speed, or my rate, in other words, would be miles per hour, okay? Now I know sometimes you'll see it like this, mph, miles per hour, okay? All right, so, there wasn't a whole lot of computation that we had to do on that one. Let's look at example 2 here. I'm going to start zooming in some. Example 2, it says, I purchased 6 pounds of nectarines at a price of $1.68 per pound. So here again, we see that word per. How could I find my total cost? Well, intuitively you could think, okay, well, if each pound is $1.68 and I bought 6 of those, 6 pounds, then you just multiply, right? Okay. But more formally, guys, it can be expressed this way. You can say, I bought 6 pounds of nectarines, okay? And I'm going to make this a fraction, and you'll see why here in a minute. Anytime you want to make something a fraction, you just stick it over 1. Okay, so 6 pounds of nectarines. I could even write the word nectarines. Well, nah, I don't think I'm going to write the word. That's not really necessary. Okay. At a price, so we are going to multiply here, at a price of, now when I get to this, I'm going to write this as a conversion factor. Okay, so this is $1.68. The word per means I'm going to put pounds in the denominator, okay? $1.68 per pound. So these are sort of like equivalent in a sense. 1 pound costs $1.68, and with $1.68 you can purchase 1 pound. Now, why are we doing this? Why didn't I just multiply these two numbers? Well, this helps us take into account what's going to happen with our units. This will become more evident later on. When you're multiplying fractions, guys, if you have 1 unit on top and you have that same unit somewhere in one of these denominators, you can divide it out. So what we're doing here is really dividing out the units that we don't want. So the pounds, or that unit that measures mass, is going to divide out. And so what do we have left with? Well, now we're left with just multiplying 6 times $1.68. And notice the only unit that we're going to have left over is $1. It's a measure of money. Okay. Let me get the calculator. So 6 times $1.68. And we're going to get 10.08. This is going to be in dollars though, okay? So the nice thing about setting these up this way using a conversion factor is that your common unit, or the units that you want, that you no longer want, will divide out, and then the unit that you want to have left will be left over. So see, it says, how could I find the total cost? Well, it's right here. It's $10.08. All right, the next one, example 3, is very similar. It says, how much will you earn working for 6 months at a salary of $3,200 per month? So I'm going to do this one essentially the same way. Okay, I'm going to start with 6 months. So in this case, my unit is months. It's a measurement of time. So 6 months times, and then this is my conversion factor. Okay, it's $3,200 per 1 month. Okay, so now what happens? Well, I have the unit month in both the numerator and the denominator right here. So that unit will divide out. And so what are we going to have left? Well, you just multiply straight across. 6 times 3,200, I believe that is 1920. I think that's right. We have dollars left over. Okay. Now notice in the denominators here, guys, we have 1 times 1. Well, if all you're going to have in the denominator is 1 times 1, you don't need to keep it. You can just forget about it. Okay. Sometimes, though, you'll have other numbers left down here that you'll have to multiply and put them in your denominator over here and then divide at the very end. So I just want to point that out. And you'll notice that our result is in dollars. Okay. Oh, wait a minute. This is not correct. I think it should be. I missed a 0, didn't I? I knew that didn't look right. Yeah, there we go. Yeah, just forgot the 0. Okay, $19,200. All right, well, we'll continue on. All right, well, we've already talked about area some. Okay, so figure A is a rectangle. It's two-dimensional. It has a length, and it has a width, or a depth, or a height. It doesn't matter what we call it. Okay, it just has 2 dimensions. And the way we find the area is by multiplying the length times the width. Okay. Now, figure B is actually a cube, or a 3-dimensional rectangle. Okay. Not only does it have length and width, or you could call it height, but it also has this 3rd dimension, depth, and that's what makes it 3-dimensional. All right, so we get just a little practice. So it says find the area of the figure given that the dimensions are 3 centimeters by 18 centimeters. So figure A is 2-dimensional, so we can say that this side is 18 centimeters and this side is 3 centimeters. And if I want to find the area, I multiply those. I say 3 times 18. Well, technically you're multiplying these 2 units as well. 3 times 18 is 54, but a centimeter times a centimeter is a square centimeter, okay? Using exponents, just like you say 4 times 4 can be expressed exponentially by using an exponent of 2. So that's how we get that square unit. So anyway, 54 square centimeters. Okay. Now sometimes in your homework, in lieu of using a 2 in the exponent to describe a square unit, they'll literally use the word square. But anyway, let's continue. It says find the volume of the figure given that the dimensions are 8 inches by 4 inches by 3 inches. Okay, so it's only figure B that has volume. And if its dimensions are 8 inches, and we'll say this side right here is 4 inches, and then the depth right here is 3 inches, then it's the same thing. You multiply all those dimensions to get the volume. So it would be 4 inches times 8 inches times 3 inches, and I believe that's going to be 96. But now our unit is going to be cubed, because we have an inch times another inch. That's a cubic inch. Okay, that's a measure of volume. So in any case, this is going to become 96 cubic inches. Let's see here. The next question says, state the area of the smallest face of the rectangular solid described above. Well, this is the rectangular solid. The smallest face would be the face that has the two smallest dimensions. So it's probably going to be this face right here, guys. This face, or there's another face at this end that you can't really see, that's kind of hidden there. But it's 4 inches high, and it's 3 inches wide. Okay, so if that were the case, the area would be 4 inches times 3 inches, and it would be 12 square inches. Okay, so the smallest side of this rectangular solid would be 12 square inches. Now these other faces, they would have more area. All right, the unit of measure for area is, we're just going to say square units, okay? Because it doesn't have to be feet. It could be square yards. It could be square miles. If you guys keep up with wildfires in the West, they describe those lots of times using square miles because, you know, they can be quite vast. And then the unit of measure for volume is going to be a cubic unit. Oops. All right, so we'll keep going here. I think I'm going to get about roughly halfway through, and then we'll stop this video and then do a second part. And I would also like to look at a couple examples from your homework with you as well. Okay, example 4 here. It says a raised flower bed is 25 feet long, 8 feet wide, and 1.5 feet deep. So it basically has this shape right here, except it's just more elongated probably. Find the area of the bed and the volume that it holds. So what I'm going to do, first of all, I'm going to sketch this out. Okay, so let's say this is a two-dimensional side view of it, and it's 25 feet long. Let's see, it's 1.5 feet deep, so that's like the height. Then because it's three-dimensional, it is 8 feet wide. Okay. Now when it says find the area of the bed, that means the bottom. So there's part of this that you can't see. Okay, you can't see this face, nor can you see the back side or the bottom face. Okay. Well, when they ask for the area, they're literally meaning this bottom. How big is the bottom? How much area would this take up on the ground if you were to put it in your backyard? Okay, so to figure that out, we need to figure out the area of that side, or not side, but rectangle. Well, it's 25 feet long times, and then it's 8 feet deep, or 8 feet wide, excuse me. So times 8 feet, and that's going to end up giving us 200 square feet, okay? So it's 200 square feet in the area. Now the volume, or in other words, how much this three-dimensional rectangle or flower bed would hold, is going to be found by multiplying all three of those dimensions. So 25 feet times 8 feet wide times the depth, 1.5 feet. Okay. And if we do this, I know that 25 times 8 is 200, and if I multiply that, this is like 1.5, it would give me 300. But this would be in cubic feet now, because we had these 3 feet that got multiplied together. Okay, so this would be a cubic unit. All right. Guys, I think I might stop this video right here. This maybe will be the end to our part 1. I try to not keep these past close to a half hour, but the next thing we're going to get into is using these conversion factors. So we've already used them some up here, you know, but we're going to be pretty much exclusively using them down here. And these are some examples, you know, 12 inches over 1 foot. That, you know, 12 inches is the same as a foot, so this allows us to use 2 different units, and this is still has a value of 1. But depending on which unit we want to cancel, that determines how we orient this conversion factor. And you'll see what I mean whenever you watch part 2.